All right, so today we're going to talk about solving square root equations. And before we get into that, we're just going to review really quickly how to solve any sort of equation using graphing. So we've done this in previous units. So remember, if you're solving an equation graphically, you're going to graph both sides of the equation. So for example, I would consider this equation as y is equal to negative x squared plus 4. And if you notice, that equation corresponds with the red parabola. And then I would do this side of the equation as y is equal to negative 5. So that corresponds with this horizontal blue line. The solution to that equation is where the blue line intersects the parabola. So we would say that the solutions are negative 3 and positive 3. Notice we're solving for the x value, so that's the part that we care about. Or if we had a square root function right here, if we again set each side equal to y and graphed it, we would have a square root function that's been moved to the left 5, and we would have a horizontal line at positive 2. The intersection point again is negative 1, positive 2, and our solution then would be x is equal to negative 1. So keep that in mind as we start this procedure. So first, just good step-by-step instructions for how to solve square root equations. So the first thing you want to do is isolate the radical. If you have more than one radical, you need to try to get one radical per side. After that, you're going to raise both sides to the power of the index. So if it's a square root, you're going to square. If it's a cube root, you're going to cube, and so on. And then finally, you're going to solve for the variable. Now, if you have more than one radical, and let's say the first time you solve, you end up again with a radical, then you're going to go back to the beginning and repeat the process until you've gotten rid of all of your radicals. The final thing, which is really, really important, is to check your answers in the original equation, because sometimes you're going to have answers that don't work when you plug back in. So that's a super important step. Okay, so we're going to solve both of these graphically and algebraically. So the first thing is, let's go ahead and set each side of the equation equal to y so we can graph the function. I want you to notice that we've got a square root function that's been moved left 3 and up 2. So I'm going to start right here. And then we don't have any sort of stretch or compression, so I'm going to go up 1 over 1, up 1 over 3, up 1 over 5. And I can connect my dots, and I've got the square root function graphed. The other side is a horizontal line that crosses the y-axis at positive 4. So it's going to look like this. And if we zoom in on that, we see an intersection point right here at the point positive 1, positive 4. Remember, we're solving for x, so we care about the x coordinate right there. So what we find is that our solution here is x is equal to 1. Now let's do that algebraically. So we'll just go through the process that's listed above. So the first thing we want to do is isolate our radical, so we're going to subtract 2 from both sides. At this point, all we have on the left side of the equation is the radical, and then the other side has just a constant. At this point, what we can do is square both sides. Because that's a square root, to get rid of it, we square it. So then we end up with an x plus 3 is equal to 4. And then subtract 3 from both sides and find, again, that x is equal to 1. Now, we know that this works because we've solved it graphically, but you can always go back in, and you definitely need to go back into the original equation, the very, very, very first equation you saw, and we're going to plug in our solution and make sure it works. So 1 plus 3 is 4. We're going to do the square root of 4, which is 2, and 2 plus 2 does, in fact, equal 4, so we can be confident about our answer. All right, next question. We'll do the same thing. If you feel confident on this, I would suggest pausing the video and working it and then scrubbing through to see if your answer is right. So here we want to isolate our radical. So I'm going to go ahead and subtract 1 from both sides. So we end up with the square root of x plus 5 is equal to x minus 1. Now we square both sides because we're dealing with a square root. So on the left, we have an x plus 5. On the right, make sure you don't kill any puppies. You're thinking x minus 1 times x minus 1. The shortcut is it's always this term squared, and this term times 2. So it'd be a negative 2x. Now we continue to solve. So we're going to isolate our x. Notice now we're dealing with a parabola on that side. So when we want to solve quadratics, we want to set the entire equation equal to 0. So I'm going to subtract 5 from both sides. So I'll have x is equal to x squared minus 2x minus 4. And then I'm going to subtract x from both sides. So I end up with 0 is equal to x squared minus 3x minus 4. Now This is factorable. We want to find the factors of -4 that add to -3. So hopefully you're thinking it's going to be x minus 4 and x plus 1. So our solutions mathematically there would be 4 and -1. Okay. So let's look back at our original equation, and we're going to graph this. For our first side of the equation, which we're going to set equal to y, we've got a square root function that's been moved left 5 and up 1. So I can go ahead and transform my function. Nothing's been stretched or compressed, so I'm going to go up 1 over 1, up 1 over 3, up 1 over 5. So here's my square root function. And then if I set this side equal to y, I'll have y is equal to x. Remember, that's the linear parent function. So it passes through the origin and it has a slope of 1. If I continue that, I want you to notice this has only one intersection point. But look down here, we got 2 different answers. The reason we got 2 different answers is that when we square a square root function, think about when we did inverse functions. If we are trying to find the inverse of a square root function, we initially get a parabola. And look, this right here, that is a parabola. So when we do the inverse of a square root function, we initially create a parabola, but then we have to kind of restrict the domain. So I want you to look at this. Notice this was the positive root here, and we needed to keep the positive square root. It's going up and over rather than down and over. So what that means is that we're going to keep our positive solution here. Now, always check yourself mathematically, though. So if we plug in 4 into our original equation right here, we get the square root of 9 plus 1, so that'd be 3 plus 1, and we're asking ourselves if that equals x, which our x is 4. And that one works. But watch, if we were to plug in a -1 right here, we get -1 plus 5, which gives us 4. Then the square root of 4 plus 1, so that'd be 2 plus 1. And we want to ask ourselves, does that equal -1? And it doesn't. Why is it? Well, it's because when we squared it, we created a parabola. So it'd be like if we were to do this, the other side of the parabola right here, it would intersect right there. But that side of the parabola, it doesn't exist because we're dealing with a square root function and not a quadratic. Okay, example 3. We're going to go ahead and just do these algebraically, but don't forget about the graphical relevance of the intersection point. So here, let's go ahead and we're going to isolate what's going to be our radical. Remember, a rational exponent is the same thing as a radical, so we're going to subtract 3 from both sides and get 4. Now, let's go ahead and write this in radical form. So I'm going to go ahead and make the top the power and the bottom the root or the index. Now remember, we're going to raise both sides to the power of the index. Well, if the index is 3, then we need to cube both sides. At this point, we have 5x minus 2, that quantity squared because of this, is equal to 4 to the 3rd, which is 64. So now we square both sides. Remember, don't kill puppies here. It's 25x squared, so it's this squared. The last term is going to be -2 squared. The middle term is going to be this times 2. So 5 times -2 is -10. -10 times 2 is -20. Now notice we are dealing with, I should have put a square right there, we're dealing with a quadratic, so we want to get the equation set equal to 0. So we have 25x squared minus 20x minus 60 is equal to 0. So here you can go ahead and factor it and solve from here, but it's a lot easier if you factor out the greatest common factor. So we can factor out a 5 and get a 5x squared minus 4x minus 12. Set that equal to 0. And we could essentially just like divide everything by 5, and then that's gone. We really only care about that 5x squared minus 4x minus 12. So now we go back to our quadratic unit, and we're going to have to factor this by whichever method you chose. You can multiply 5 and -12 and find the factors of 60 or -60 that have a sum of -4. Or you can slip and slide or whatever method you want to use. When you factor this, we're going to get an x minus 2 times a 5x plus 6 is equal to 0. Now back to the quadratic unit, we end up with x is equal to a positive 2 or a -6 over 5. Now, remember, we have to check our answers. So we're going to plug in a 2 for our x value, and then we'll plug in a -6/5 for our x value. So let's go up here. We're going to go to our original equation. Now, I probably would go ahead and rewrite the 5x minus 2 to the 2/3 power. I would probably just rewrite this as the cube root of 5x minus 2 squared, and then plus 3 is equal to 7. So let's plug in a 2. So we get 5 times 2 minus 2, and we're going to square that. And we're asking ourselves, does that equal 7? So 5 times 2 is 10, 10 minus 2 is 8, and 8 squared is 64. So if we find the cube root of 64, that number is 4, and 4 plus 3 is equal to 7. So that one works. Now let's try our second one. If we plug in a negative 6/5, we can multiply 5 times negative 6/5. That's going to give us a negative 6 minus 2. If we square that, negative 6 minus 2 is 8. 8 squared is 64. And again, our cube root of 64 is 4. And 4 plus 3 is equal to 7. So in this case, both of our solutions do end up working. The quick answer as to why this is because this is not a square root, it's a cube root. So you do end up having like two sides of this equation. All right. Last example, and then you'll have some to do on your own. And this one's the messier one because we start off with two radicals. So the first thing we want to do is we want to get just one radical per side. So I'm going to add root x plus 6 to both sides. So I'll end up with the square root of 3x plus 6 is equal to 2 plus the square root of x plus 6. Now we're going to square both sides. So on the left side, we've successfully gotten rid of our radical, but on the right side, so we'll multiply 2 times 2 and get 4. Then we'll multiply 2 times root x plus 6. So we just end up with 2 root x plus 6. And then here, again, 2 root x plus 6. And then when we multiply these two, it's like squaring a square root. So we just end up with x plus 6. So I'm going to clean this up a little. And we can do some combining like terms on the left. So we end up with a 3x plus 6 on the left, and on the right we'll have 10 plus x plus 4 root x plus 6. Now notice we don't have our radical gone. We still have one left. So we need to go through the process again. So we're going to isolate our radical. So we'll have 3x minus 4 is equal to x plus 4 root x plus 6. And then we'll subtract x from both sides and find 2x minus 4 is equal to 4 root x plus 6. Now here, if you wanted to divide both sides by 4, you could. I chose to just go ahead and leave it and square both sides here. So again, don't kill any puppies here. It's going to be a 4x squared. We're going to multiply that times that and double it. So it'll be minus 16x, and then we'll square this. So plus 16 is equal to, now this, we're going to have to square this. So that'll be a 16. And then when we square this part, squaring a square root makes it just an x plus 6. Okay, at this point, I went ahead and divided everything by 16. So I end up with 1/4 x squared minus x plus 1 is equal to x plus 6. Now I'm going to subtract 6 from both sides, and I'll have 1/4 x squared minus x minus 5 is equal to x. Notice again, we're working with a quadratic, so we need to get everything on one side. So I'm going to subtract x from both sides, and I have 1/4 x squared minus 2x minus 5 is equal to 0. Okay, you can try to factor this as it is. What I did, because I don't like that fraction there, is the rule of whatever you do to one side of the equation, you do to the other, works for this. So what I chose to do was get rid of my fraction by multiplying the entire equation by 4. As long as you multiply both sides of the equation by the same number, you're in good shape. So here we can say we have x squared minus 8x minus 20 is equal to 0. And now this is an easier quadratic to factor. So I'm looking for the factors of negative 20 that have a sum of negative 8. So hopefully you're seeing it's going to be an x minus 10 and an x plus 2. So we have two solutions. One is positive 10 and one is negative 2. But this is one I'm hoping you see that because in the process of solving, we created a quadratic right here, then we went from something that had one arm to something that has two arms. So we're going to end up having one of our solutions not work. Let me go back up to the top of this page. There's a name for those extra solutions that don't work, and they're called extraneous solutions. So just a good vocabulary word to know. So let's figure out which solution is the extraneous solution. I think you could probably look at this and see that it's going to be the bigger one or the positive one. But just to make sure, go back into your original equations. So I'm going to go ahead and clean this up a little. And we're going to plug in a 10 first. So we have 3 times 10. So that's 30. 30 plus 6 is 36, and the square root of 36 is 6. And then for x plus 6, we're going to plug in a 10. We'll get 16. The square root of 16 is 4. And then 6 minus 4 is 2. So we like that one. Let's try negative 2 now. So if we plug in a negative 2 for x, we get 3 times negative 2 is negative 6. Negative 6 plus 6 is 0. And the square root of 0 is 0. And then here, negative 2 plus 6 is positive 4. The square root of positive 4 is 2. But notice it's a subtraction sign right there. And negative 2 does not equal positive 2, so this is our extraneous solution, so we can get rid of that negative 2. All right, now I encourage you to try these questions and then check your answers based on my work. So the first one, we're going to subtract 2 from both sides because we need to isolate our radical. We have 3x plus 10 is equal to 2 then. Now we square both sides to get rid of our square root, so we end up with 3x plus 10 is equal to 4. Then we subtract 10 from both sides and get 3x is equal to a negative 6, and then divide both sides by 3 to get that x is equal to negative 2. The next question, I'm going to go ahead and write this in radical form. So this is x minus 1 quantity squared, and we're doing the cube root of it. We want to raise both sides to the index. So we end up with x minus 1 squared is equal to 4 cubed. We're going to go ahead and FOIL this. It's going to be x squared. Then we're going to multiply x and negative 1 and then double it. So it'll be minus 2x, and then we'll square negative 1. So plus 1 is equal to 4 cubed is 64. We subtract 64 from both sides and get x squared minus 2x minus 63 is equal to 0. We can factor that down into x minus 9 and x plus 7. So our solutions are x is equal to a 9 and a negative 7. If we plug those back in, we get, I'm going to look at this one because notice I didn't change anything. I just put it in radical form. So if I plug in a 9 right here, I get 9 minus 1, so that's 8. 8 squared is 64, and the cube root of 64 is 4. So that one works. If I plug in instead a negative 7, negative 7 minus 1 is negative 8, but negative 8 squared is still positive 64, and the cube root of positive 64 is still 4. So there are no extraneous roots on that one. All right, so for problem number 3, I'm going to go ahead and write it in radical form. So we'll have 2x plus 3, it's the square root of that. I'll subtract 8 from both sides and find that this is negative 2. Hopefully at this point you're recognizing I don't have any i's anywhere, so this is basically saying what number can I plug in for x here so that the square root is a negative 2. Well, it's asking for the positive root of it. So hopefully you're thinking that doesn't make any sense, so this one is going to have no solution. And if you didn't recognize that and you continued going, here's what you would see. We would end up with 2x plus 3 is equal to 4. So 2x is equal to 1. So x is equal to 1/2. So when we plug that back in, I'm going to go ahead and plug it back in, but I'm going to go ahead and do the square root. So I'll have a 2x plus 3 plus 8 is equal to 6. So if we plug in a 1/2 for x, we end up getting that this is 1 plus 3 is 4. So the square root of 4 plus 8, square root of 4 is 2, and 2 plus 8 does not equal 6. So here, this is an extraneous solution, so there is no solution for this one. Okay, next question. This one's one of those long, messy ones. First, we want to go ahead and isolate our radical so that there's only 1 on each side. So I'm going to add square root of x plus 4 to both sides. So now 2x plus 1, I'm going to square both sides. When I do that, I've successfully get rid of the radical on the left. But on the right, remember, we're going to have to FOIL this. So this is going to end up being this squared, so 1 plus this times this doubled. So that's going to be a 2 root x plus 4. And then this squared, so plus x plus 4. All right, now we still need to isolate the radical again. So this is kind of a two-step process. So if you recognize, if we do 1 plus 4, that gives us 5. So we're going to subtract 5 from the left to get rid of that. And we're going to subtract x to get rid of that. So we end up here with x minus 4 is equal to 2 times square root of x plus 4. Now I'm going to square both sides. At this point, we have x squared, that squared, this times this, so negative 4x doubled, so negative 8x, and then this squared, so plus 16, is equal to 2 squared is 4, and when we square a square root, we get x plus 4. Now we can solve this. So we can distribute the 4 across, or you can divide first if you want to, but I would go ahead and distribute the 4. So we end up with a 4x plus 16 is equal to x squared minus 8x plus 16. Now we're going to subtract 16 from both sides. That goes away. And we're going to subtract 4x from both sides. So here we end up with x squared minus 12x is equal to 0. Don't get messed up by this because all you have to do here, since you have a binomial, the only thing that you can factor into two binomials is if this was a difference of two squares, and it's not. But remember, the very, 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 very first thing to look for in your factoring is if you could just factor out a greatest common factor, and in this case we can. So our two solutions initially are x can be 0 or x can be 12. Hopefully you recognize that this is going to have an extraneous solution. So we're going to go back in and we're going to plug in those two numbers. If I plug in a 0 here, 2 times 0 is 0 plus 1, square root of 1 is 1. If I plug in a 0 here, 0 plus 4 is 4. The square root of 4 is 2. And notice 1 minus 2 is negative 1. It does not equal positive 1, so that is our extraneous solution. Let's go ahead and plug in a 12 and see if that works. So 2 times 12 is 24. 24 plus 1 is 25, and the square root of 25 is 5. And then 12 plus 4 is 16. The square root of 16 is 4, and 5 minus 4 does in fact equal positive 1. So we're going to eliminate 0 as our extraneous solution, and our final solution is positive 12. And the last one, let's go ahead and get our radical by itself. We'll have the square root of 2x plus 1 is equal to x minus 1. We'll square both sides. We have 2x plus 1 is equal to, here we're going to say x squared. Then we're going to do x times negative 1. That's negative 1x times 2 is negative 2x. And then we'll square this to get plus 1. Let's get both sides, or get one side equal to 0. So I'm going to subtract 2x and subtract 1. So I'll subtract 2x here and subtract 1 right there. So we end up with 0 is equal to x squared minus 4x. Positive 1 plus negative 1 is 0. And we can factor out an x. So our x is equal to either a 0 or a 4. Again, we went from a square root function, which only has one arm, to a quadratic function, which has 2. So we're going to have an extraneous root. Hopefully you know which one it is, or have a good guess as to which one it is, but let's check it. So 2 times 0 is 0. 0 plus 1 is 1. The square root of 1 is 1. And then minus, if our x value is 0, notice that does not equal negative 1. But if we plug in a 4, 2 times 4 is 8. 8 plus 1 is 9. The square root of 9 is 3. Minus, if our x is 4, 3 minus 4 does in fact equal negative 1. So we eliminate 0 as one of our solutions and keep the 4. All right, see you guys next time.